In the world of utilities, the ability to monitor outlier usage activity on the power network has become a major requirement. This ensures that the power generation companies can easily determine the dwellings across city or town districts that are consuming the most power and can dynamically adjust the power network accordingly to satisfy demand or price charging rates. In this use case scenario, the assumption is that in every apartment and house there are smart plugs which monitor and send the current wattage usage as streams to the Oracle Stream Analytics platform. The shape of the streaming data is shown here. In this case, the initial properties relate to the usage values, and as we are only using and interested in the load measurements, we will filter out the work-related values during processing. The remaining shape properties relate to the unique identifiers of the plug and the house. So in summary, the goal of this demonstration, using available sample simulation data, is to calculate the percentage of plugs in each dwelling over the last hour that have an average load greater than the average load of all of the city or town plugs. To explain the analysis performed by Oracle Stream Analytics to identify outliers, here is a graphical representation showing how the time series energy usage data is plotted on the x-axis with the load value depicted on the y-axis. The white line shows the town or city average, and the remaining lines relate to each plug in a specific dwelling. For each hour, a percentage can be calculated for the number of dwelling plugs that are consuming energy above the town or city average at that point in time. Here we have the Oracle Stream Analytics catalog with some predefined connection artifacts for the Kafka messaging layer and the Oracle database. Let's start the simulation data. We now define the smart plug stream with the event shape dynamically detected from the streaming payload. Okay, artifacts created and finished. Let's create our first pipeline application. Let's kick off with the outlier percentage pipeline using the plug stream. The live output stream with the identified shape arrives on the canvas from the various smart plugs. Our first query stage will cleanse the streaming data. Using the analytical power of Stream Analytics, we can easily filter out unwanted measurement information and use only load-related data that has an energy usage above zero. The live output stream columns can be easily renamed for clarity. We now use the Expression Builder to create a new composite key column from the household and plug ID. Now we have a unique identifier for each plug for later downstream query usage. Now we create a group stage to calculate the average loads. Here we will define three aggregates. Firstly, the town or city average. The second is the plug-wise average load. And the third is the total number of plugs in the dwelling over a temporal 1 hour period. The live output stream columns can be easily renamed for clarity. Let's now create another stage to compute the outliers. Firstly, we filter on the plug average load with the city average load. Next, we calculate the number of plugs whose average load is greater than the city average load, and we can rename the resultant generated column. Columns can now be removed as they are not needed for the final analysis. Our next query stage will calculate the percentage of outlier plugs. Once again, the power of our expression builder is exposed as we create the required algorithm column and rename it accordingly. Now we have all of the information required analysis to satisfy the goal of our use case. So now we can add some very cool visualizations. The first is the percentage outlier plugs analysis bar chart. We can also add another bar chart visualization for outlier plug counts. So this completes our first pipeline application. And here is a quick review of each stage. Now we will add a target for the event shape results that will be sent to a target Kafka topic. This will be used by our next pipeline application. We now publish our pipeline to send the results to our Kafka topic. Now we want to add some geospatial analytics with this new analytical data. Firstly, we create another stream that will consume the outlier data and call it Outlier Stream. Again, notice how Oracle Stream Analytics dynamically infers the event shape from the streaming Kafka topic payload. To get all of the locations of the dwellings, we can create a database table reference for that persisted information. Again, so artifacts created. So let's create another pipeline application called Outlier Geospatial Analytics. The live output stream with the identified shapes arrives on the canvas for the house outlier event data. Now we add a query to enable the classification of each house consumption. Here we can add a new column to set the required load consumption level with a default setting of unknown. Now we will create a rule stage to classify the levels for each dwelling. Based on our consumption levels, we can set 4 category level rules: low, moderate, high, and very high, all now represented in the streaming data. Our next query will be used to retrieve all of the dwelling locations. We join to the database reference based on the house ID value to get the specific geospatial longitude and latitude positions. We can cleanse the live output stream by removing unwanted event data columns for this use case. With this information at hand, we can now create a new geospatial visualization called Outlier Map for apartment complex. We map the required column attributes, the longitude, the latitude, and the house ID, and then we save the visualization slice. On our map, we can drill down to specific locations, and we can customize this chart for the various consumption levels using color coding. Now in our drilled down spatial map for a specific apartment dwelling location, we can easily differentiate between the various levels using the various color coding. We can publish our application, here we can see we have our 2 pipeline applications running. And we can create a new operational dashboard artifact to view the created visualization slices. We add the various visualization slices to our dashboard canvas. And we are able to rearrange our dashboard slice views, perspectives, as needed for the best effect. The first view is the percentage of outlier plugs for each dwelling. Next, we have the count analysis. And finally, a geospatial color-coded representation of consumption for a specific area of interest. So there we have it. A new created powerful utilities power usage of Outlier's perspective solution with multiple pipeline applications from streaming analyzed data relating to relevant house smart plugs, which provides a valuable energy monitoring spatial and action management experience, not in days or months, but in minutes.